Hey guys, welcome. Great to see everybody. Hope everybody's enjoying their weekend here on a beautiful Saturday night. Welcome to the Asteroid Hunter channel. And we are looking at Asteroid 1998 OH. So I've been taking some images of this over the last few weeks for the Minor Planet Center, sending data in, and just kind of tracking this thing. So I wanted to kind of show you guys. I get a lot of questions on how to do this stuff, so I want to show you guys what our process is. And I know there's several ways that you can do these things as far as plate solve and those kinds of things. This is the way that we do it. We found that it's the easiest. So it seems to work for us pretty well. We have submitted a lot of data to the Minor Planet Center. I sent an email to them the other day. Their backlog, they actually had a bunch of their systems, their servers crash, and they lost a bunch of data. I don't know if they've been able to, it seems like they're getting stuff back on track, but they're pretty far behind on getting the observatory codes. They've told us that they will get us an observatory code, but they're behind, and it's kind of low on their priority list. So. But we're anxiously awaiting our code, and we've got a lot of submissions that have been accepted through there, and we've definitely submitted a number of observatory code requests, so we're just waiting for that. So in the meantime, we just continue to image these things. This was taken on July the 5th. I took these images and was tracking this thing. You can see it's slightly outside the box. They were basically needing, it was asking for data for orbital improvement. And I will show you guys how to do that and kind of the steps that we go through, even starting at the where to search this stuff up at the Minor Planet Center. And feel free to ask questions. By no means am I an expert by any stretch. My son and I, we just do this out of our backyard, and we've kind of learned as we go. And we've been pretty fortunate to have some great support from people and telescopes.net, as well as there's a lot of stuff on the internet to be able to track and understand and get information on this stuff, guys. So feel free to ask any questions that you can, and we're monitoring the chat. Chris Thompson, welcome, man. Great to have you here, and just great to have people here tonight watching the stream. So I'm going to go to, let me do this. So what I'm going to do is I'm going to start this. I'm going to stop this right now. Basically, we're blinking through these images. And I'm going to kind of go from start to finish on this for you guys, just so you can see how we essentially find the asteroids and then put them into Astrometrica, plate solve them, and then just be able to get the data real quick. So I will essentially close these out, and we're going to start from scratch on this. In fact, I'll even close the software out. So what I will do is just kind of talk you guys through it. So what we normally do is we go to the minorplanetcenter.net. And you can even see they had a recent service disruption. So this is in here. Let me change screens over here. This one's over there. So just switching the cameras around. You can see they had a recent service disruption here on June the 5th. And machines hosted caused some disk failures. And they had several observations, pipelines, and stuff going on there, but they were able to get things back online and be able to get some of their data back. So I know they're still working on this, and this seems to be updating quite a bit. So yeah, just checking this camera here, make sure that's working good. Okay, so basically we start here with the observers, and we go down here to NEO services. And we go to this observation planning aid. And this is basically what we look to see what needs measurements and what doesn't. And you put this in here, and you have this basically this object list, this planning aid that comes through. And there's a number of items in here. There's a few that we change, but for the most part, we kind of leave them as defaults. And again, I found some of this information on the internet. You can actually go in here and change whatever you feel is necessary. This is what works for us because we found some gentleman, a guy using this, and it seemed to work for us. So we'll go through, and I actually changed some of these ranges in here, but not all of them. Most of them stay all at the default. So what I'll do is I'll change the motion range from 0 to, and I want to look 360 degrees around RA, so it's full circle around us. And then my declination range, even though the plus 90 is kind of behind our house, I can't really see that, but I just leave it there. I kind of know when I start getting up into those realms, I know that I'm going to have a problem. But my horizon, I've got a hillside, and negative 25 is about as low as I can go. If I start going below that declination range, then I'm into a mountain and I can't see. So that's where I change that to. Now it says magnitude 21.0. Well, we have an 11-inch scope. We're getting about 17-ish with that on really good nights. I've been able to measure 17.1 before, 17.3, like in the low 17 range with our Hyperstar on our 11. So I just put it to 18 just to see. And I leave all these the same, with the exception of the motion range. I changed to 222, so we get the full range of any asteroids that are rolling through. And then I change this uncertainty to 0, to 1800 arc seconds, so we get the full range here. The objects everything else we leave the same. Lower galactic latitude, I leave that all at default. Only show objects not seen in more than 1 day. Anything that's hasn't been seen in 2+ days is probably lost at this point. You can put, we have 2 in there, but I generally just do 1 day. Anything beyond that can be a lost object. If you're looking 3 or 4 days and they haven't seen it, it's probably lost. So everything else we essentially leave the same. And then what I do is I sort this uncertainty to decreasing order. But everything else I just leave the same. I don't mess with it. Just keep it all at default. And then down below here, there's a produce. It's behind my image here. Let me see here. No, that's not that one. It is going to be. You can see this produce object list is sitting there. So you're just going to hit that button, and then it'll come up with this object list. Now, these boxes generally won't be checked, so I check through all these boxes, and then I get the ephemerids. Okay, and then this will come up, and essentially it will show me what you're looking for is now. This is from uncertainty from decreasing order, so usually the ones that are uncertain are at the top, and it'll say useful for orbital improvement. So anything that says useful for orbital improvement is generally stuff they're looking for data on. As you farther go down, now you can see 1998, they still need data on it. So anytime you're seeing that, that's what you can try to gather data on these things. Some of these say not necessary. That means they already have the orbital data. And this is just kind of showing what's up at this point. So you can start scrolling through here, and you start seeing what's useful and what's not. But basically what I'm looking at immediately is my magnitude, which is basically right here, this V letter down. So I'm trying to see stuff that's, 17.7. It's like we're definitely, it's not very bright at all. And then I start looking at the RA. Right now, when the sun goes down right above our head, we're at about 15 is our RA. So this would probably be farther to the west, and I would have a problem because I got some trees down there. So I tend to look at the magnitude, and then I tend to look at the RA and just to see. Now I know 52 is going to be just past above our head here, but I can definitely see that. So this one I may not be able to get this one because of where the right ascension is of it based on my location. Others obviously will vary. So I just kind of go through this. SV222, we did take some measurements on this asteroid, and it has changed in value. It was at 16 the other day, so it's moving away from us, as you can see. So 1998 as well is moving away from us. What I measured is in the 16 range. That's what we were looking at, and I'll show you guys that. AU30 doesn't need any orbital improvement. This other one was showing RO36, again RA12, 52. It's a little bit farther away. There was one I saw the other day that I was thinking, we probably should try to, this guy. So this one, 16.8, we probably could catch this with our 11. The only Bummer part is it's at 20, so it's probably coming up about 2 o'clock in the morning or so. So you just want to look at these declination numbers and your magnitudes and get an idea of what you're shooting for. So once I decided, it's like, okay, you know, we're going to go for 1998 OH. The deck numbers are here. Now, I'm going to try to do this for you guys if I can. I didn't test this. Normally I do. But I use Stellarium. And Stellarium basically will carry you can upload these the Minor Planet Center data right to Stellarium, and it'll pull in right where this stuff is located, right off the software itself. So let me do this. Let's see if I can. I'm going to try to remote into my other computer here to see if I can get you to see this. Okay, so here's Stellarium, and it's remoted off. Oh, let me see here. We're going to apply that. Let's try that again. Let me relaunch that. You're looking at basically in my 3 screens, you're looking at this screen right here. This is a separate computer that I have running Stellarium and these other software. So let's see if I can get this thing to open. I just want to show you guys, but basically you can upload data. So if you go to your configuration window and you go in here to plugins and you scroll down here to Solar System Editor, okay, and you do configure, and you go to Solar System, you can import orbital elements in the MPC format. You click that. And then if you go in here to this bookmark page, you can scroll down and you're going to see these near-Earth asteroids or elements of NEAs for current epochs today. So if you click those, and then you can download those lists right into Stellarium, and it'll go right in there. You don't even need to write down the RA and deck number out of the Minor Planet Center because it takes it for you. And then when you do a search, let's see if it'll come up. There's my search window. So if I type in 1998 OH, you get a space in there. See there, it's coming up right there. And you hit search, and right now that's where it's sitting in the sky. So 9 times out of 10, I don't even have to manually put in RA and deck numbers. It's already going to come up in Stellarium for me, and that's going to tell the telescope exactly where to go. So as long as I know what asteroid I'm going for, it's going to come up right in there, you know. So let me switch back. I'm going to disconnect out of there. Put this server back online. Okay, so let me switch over there. So basically, what we do at this point is we use SharpCap, and we shoot FITS files in SharpCap, and we used 60-second exposures. That's pretty much what we take with our Hyperstar. So, and what I will do is once I start, let me put this up here. Once I start shooting, I will immediately it'll start putting images into my folder on my drive. And what I will do is I usually do 31-minute exposures. So I have 31-minute exposures going. Once I've done the first one, then I will use this astrometry.net. Now I use this a lot for my plate solve. It works extremely well. I know there's other ways to do it. This is just how we do it, and it works extremely well for us. And I love this website. So basically what I will do is I will just immediately, to make sure that I have the correct, I'm literally looking at the asteroid. I will, once I get that first image, so I'll point it to, I can do this upload, and I'll point it, and it starts putting images into the folder as it's taking them. I'll grab that first one while I'm imaging, and I will upload the first one. And you can see right here it says uploading, okay? And what it's going to do is it's going to give me my exact RAN deck for that particular image, and have that in there. The other thing that you guys want to make sure that you're running is some kind of a master clock on your computer. I use Dimension 4, and what this does is it syncs with master clocks around the world to give you your UTC time. And what that will do is put time. You have to have this for the Minor Planet Center. You've got to have your images have to have the correct clock on them. And what it'll do is put an actual timestamp on your images. So this is running in the background. There's lots of other ones. You can also use NEA time as well. I use that as well. Works really well. But Dimension 4 seems to work great for us, and that's just always running in the background on the system as well. So you can see that it's still uploading, and it's almost done. And then what it's going to do is it's going to do the submission. Now, while that's happening, I will just open up Astrometrica. And Astrometrica now, when you're submitting stuff to the Minor Planet Center, you have to use this new ADES format that is written into the new Astrometrica beta that's out there, and it works just fine. And it's saying right now you want to replace existing files because I did a measurement the other day, so there's actually files sitting there. So I'm going to create a fresh new batch. So what I will do is I will import that one image that we have uploaded to astrometry.net. Okay, that's the first one. And you see it's time-stamped. So that's comes from the Dimension 4. So that's already time-stamped in there. Okay, and then I will switch back here, and it says go to results page, and it's waiting to process. And it's just going to tell me, give me my RN deck. Now sometimes this website sometimes is a little slow, but most of the time it works extremely well. It's already started processing. So, kicking back, and there, boom, it gave. So now it's plate solved this image, and it's given me my RAN deck. So what I will do is I will go up here to data reduction on this image, and I'm going to input this number into my right ascension and deck. Okay, which I was messing with this earlier, make sure it's working, so it's already there. And I'm just putting that figure in there for that specific image. And Astrometrica will always go not responding, but you always just let it go. See, and it'll just keep going. And 9 times out of 10, it doesn't reference. So it says, hey, it says there's been 37 stars detected, but it needs to do an actual star match. So you hit OK, and then you can do this manual alignment. Now you see right now it's reading up to 17 magnitude. So what I normally do, and that's why it's showing all these stars, it's basically showing up to 17 magnitude in this image. So I'm going to back this thing way down to I can see there's like 3 or 4 bright stars in this image. So I'll back it down to about 9. And basically what I'm trying to do is align those red dots with the stars in the picture. So I have put in the focal length of our instrument. The focal length with Hyperstar is 530-ish focal length. You have to adjust this once you've gotten into Astrometrica a little bit, but you always want to put. Now we're shooting with actually a 2200 millimeter telescope, but because we're shooting f2 with a Hyperstar, it takes it to 530 focal length. So I don't mess with this. This is the sweet spot for this thing. I've already figured that out. Now I'm just going to mess with the position angle, and just the twist of the camera is all it's doing, is twisting the camera. And you can see I have now aligned those red dots in there. And I will zoom in a little bit, and then what I'll do is I'll start bringing back some of the magnitude, some of the red dots. Okay, and you can see it's all aligned. You hit OK, and boom, it just star matched. So it's now plate solved the image. So then what I will do is I will go over here. Now I've plate solved the image so it knows exactly where it's at in the sky. And I will go to this known object overlay. I will click on this, and it's going to basically tell me what asteroids are overlaid in this image. Now right now, that's the asteroid we're looking for. Remember, it's 19OH, and it is, let me see here, 12538, 19OH. It says 12538. So that's the asteroid right there, and that's actually it, just outside the red box. So we know that we are looking at the correct spot in the sky. Sometimes I'll load this and there will be no overlay, or the asteroid won't show, and I'm like, I'm not in the right place in the sky. And sometimes I'll slew off, and I might have to manually put in the RA index, but 95% of the time, Stellarium will take me right to it. Now, this was Stellarium taking me basically right to where the asteroid was. So now I know, as I'm imaging these 31-minute images, I know I'm looking in the right place. Okay, so we already know, what our according to our RA and deck, based on our astrometry.net, we know that basically that is our first image that we are gonna start out, and that's where we start our blink process. So we got a question. Hey guys, I know a little off topic. What type of computer you remote into? A mini PC or a stick? We don't remote into anything, Chris. We're actually we actually shoot into we set up our telescope outside, and I have cables running outside, and they're basically talking to. I've got two PCs going on right now. You see the big red tower? That's my main machine that I'm streaming on, that I'm running Astrometrica on, that I'm basically doing all the imaging on. And then this little guy, this little box that you see right here. Let me get you. You can see that fan. That's another. These are custom computers that my son and I built. And that machine is controlling these two screens, which is running Astrometrica, or not Astrometrica, I'm sorry, Stellarium. And then I use PH2D guiding to guide the scope. I found that I have to use PH2 guiding to guide 60-second images with our 11-inch. It's a little bit heavier. With my 8-inch, you can see in the back, we got our 8-inch right back there. That's wrapped with Asteroid Hunter logo. We're going to show you guys that another stream. I don't have to guide with that because it's such a light scope. It works so well on the CGX mount that the weight and stuff, I don't have to guide with it, man. It'll track 60-second images, no problem. But with the 11, more weight and stuff, I need to use the guiding, and the guiding works extremely well. So yeah. So basically, I want to try to keep this thing short for you guys if I can. But basically, we've shot our 31-minute images, and we have put the first image into astrometry.net. We've uploaded them, and we have our RA index for that first image. So then what I will do is I will import all of the images. Now, I won't import all 30. I will import each one of them 5 minutes apart. So there's one. That one's 5 minutes apart. There's another 5 minutes apart, 5 minutes apart, 5 minutes apart, 5 minutes apart, 5 minutes apart. Now, people say, well, why, you shoot all 30. It's like sometimes image 30 is no good. An airplane flies through the middle of it. We got to use image 29. Sometimes there's a shooting star. Sometimes there's something in the image. Sometimes the wind blows, and these two images are bad, and I have to use one of these. So the whole point is just try to get a few images 5 minutes apart is kind of the sweet spot. So I'm just going to literally grab this 1, 2, 3, 4, 5, 6, 7 images, all 5 minutes apart, and open those up. They're time stamped automatically. I didn't have to put those in. Astrometrica just writes them in for me. And I'm going to import these files. Okay, so there's the 7 FITS files. Now I'm going to go to file number 1, the one we did earlier. That's what I will start my plate solve. File number 1. Always start your plate solve with that first file. That's where you're going to blink from. And I'll do exactly what we just did. I'm going to hit that data. What's it called there? I always get the names wrong. A data reduction button, which kind of looks like PH2D's guiding button. And I'm going to literally put in that RA and deck that we got from our astrometry.net when we uploaded that picture into that thing, which is already there. I'm going to hit OK. Now, because there's 7 images there, it's going to take a little bit longer because that's what Astrometrica does. And it says not responding, and you sit here and you just wait, and you drink a little glass of water, and you say, oh my gosh, it's not responding. Yes, Chris. In fact, we're shooting. Chris is asking, could you go lower, say 30 seconds if you have a Raza? Absolutely. And our Hyperstar is shooting f2 just like a Raza. We're shooting the same speed as a Raza as well. So Raza will do the same thing. I've just found that and you can do 30. I've just found that 60. It's like, obviously with Hyperstar, Raza, the longer you shoot, just the amount of light gathering is unbelievable. Now I'm sitting in the suburbs of Southern California, and we have a fair amount of light pollution here, so I'm trying to get as much data as I can, and I've just found that basically to get some of these images that are really darker, 16, 17 magnitude, 60 seconds seems to work pretty well for me. I can absolutely shoot 5 minutes, 10 minutes on that thing. See what Astrometrica did? So it sits there and says not responding, then all of a sudden, boom, it's working. Okay? So you got to be patient with it. And it's going to do the same thing where it wants a star line. But to answer your question, Chris, yeah, you could absolutely do 30 depending on where you're at. 30 seconds on a Raza or a Hyperstar shooting at f2 is like, I don't know what it mathematically is, 8 minute exposure. It's a huge amount of data that you're collecting. So for us, I just like to go 60. It works extremely well, and I can really capture these things. And you're going to see it's going to measure. I'm going to show you what magnitude we're looking at, and you're going to see how bright these images are. So I'm going to do the same thing. I'm going to back the magnitude down to where it just shows a few of the circles, and I already know, like, that's the bright star right there. And I'm just gonna do an alignment here with this thing. Rotate it through, and I will put these back, and I will zoom in. I'll just do a little bit of a touch. I'm gonna hit OK. Boom, and it didn't go. Now sometimes you got to do it a few times, and that's how that goes. So you just do it again. Just kind of go OK. Let me rotate this thing through. You got to really get them kind of lined up. Boom, there. Okay. So now we have a plate solve on this image. So then what I'm going to do is I have those 7 images. I'm going to blink the images. Okay, so now it's blinking through those images and we're plate solved. And then what I'll do is, now that we're blinking, we're going to do that known object overlay. Sometimes it's really interesting. You'll click this thing and there'll be 50 asteroids in the shot that you don't see because they're up to 22 magnitude. That are sitting in the image. It's unbelievable sometimes the amount of asteroids that are in those images out there that you don't even know. So this one's only showing 1. So, and then I will just kind of zoom this thing down and over, and there's our asteroid. Let me shut this down a little bit, and you can see there it is, and that's 19OH 12538. 19OH, just like our Minor Planet Center, 12538 19OH. There it is sitting there. Okay, and we can see it just slightly outside the box. A lot of times it's right in the box, it's dialed in. Sometimes it's slightly outside. The bottom line is that I'm looking at it and I'm going to take a measurement of it. I'm going to send it to the Minor Planet Center. The other thing you want to make sure you're doing consistently is updating the Astrometrica orbital data that comes from the Minor Planet Center into Astrometrica. So you want to do this update quite often because data changes. And I always start the night off with updating my Astrometrica to make sure I'm latest and greatest, just like updating also the Stellarium as well. I'll update, like, remember I just showed you guys how to pull the data, the orbital elements for your asteroids. I always update that as well and pull that in there. So so there it is. So basically, once we've done that, we see that that's the asteroid. Now we can start taking measurements. Now I'm going to go to the first slide. So right now it shows 25 right here. So we're going to go to slide number 1. And I'm going to, you can even zoom in a little bit more. And look at how bright that thing is. That's sitting right there. And that is 16.6 magnitude. And you can see how bright it is in that 11. It's pretty unbelievable. So what you do is you click that. You see the asteroid. There it is right there. We've centered it. and you click this object destination, and boom, it's telling me right what it is. That's 1998 OH. You hit OK, and you hit accept. Now you've measured it. It's given all the parameters in here for what the measurement is. You got a good light curve. You hit accept. You go to the next one, the next slide. Boom. Slide number 5. You get right in the middle of that thing. 16.5. Looks like a good grab right there. Hit accept. Go to the next one. Right in the middle, 16.7. Object relay destination, 1908. Hit accept. Go to the next one. You're basically going through all 7 of these slides and you're taking these measurements. Hit OK, hit accept. Go to the next one. There it is right there. 16.2 on that one. Look at how bright that is. 16 magnitude and 11-inch telescopes. It's like, it's awesome, man. Hyperstar. Gotta love it. In a 60-second image. 16.5. We're right in the middle of that thing. Hit accept, and we'll do the last one. I'm just basically going through each one of these. 16.5. Hit accept. Boom. There it is. There it is flying around. Okay, so now I've taken those measurements, and you can go up here to File, and you see this View ADS report, and these are all the measurements that we just put in, okay, for the actual system itself. It pulls the catalog we're using is a UCAC. That's what's required by the Minor Planet Center. It's showing all this information. This ADES shows a lot more data than the old format used to show. So they're now using this. It shows my scope information, my telescope, my aperture information, the observer's names, the measurer name. We have an XXX for the MPC code because we're still waiting for our code. They just tell us that they're behind on getting codes out. So we're hoping that those will show up soon. So let me just check something here real quick. Okay. Just looking at that. So yeah, basically we have this ADES format. This is what we will upload to the Minor Planet Center. We've taken the measurements on the asteroid. It shows the number of the asteroid, 12538. That's its designation. 1998 is the name, but that's the actual ID designation for it. And this report is there. So what I will do is it holds it kind of in a weird spot. You go in here to your seed disk and users, app data, local, Astrometrica. There's the report sitting right there. It's in this local disk users. That's where Astrometrica puts it. It's totally fine by me. I know where to find it, so it doesn't bother me as much. What I do is I create reports outside of that, so I have a folder sitting outside. So what I will do is, you know, I have a 1998 folder, so I would write the date, and then I would drag that ADS report into that, so you can see we have you know, lots of measurements on things that we've uploaded, those kind of things. So there's the ADS report, and I just basically pull it into its own folder that I have cataloged of things. So then what you do is you just upload it to the Minor Planet Center. So I will go back here, and I will type in. It's a PSV file is the name of the file that we're looking at. See, it says .psv, and we will upload that to the Minor Planet Center. And it says right here, submit AD's pipe separated values format. Okay, it says choose the file, and I would point it to this. I'm not going to upload it, but I'm going to show you guys what we would do. We put our email address in there under observations. It's a near Earth object. It's not unclassified. It's not a comment. So, and we would just hit submit, and it uploads it. And it will tell you immediately if you have any problems with the report. It's going to give you an error, or it's going to give you a green that says submission accepted. Okay, and then what will happen is you will get a wonderful, after a little while, you're going to get a email from the Minor Planet Center that says submissions with your lines have been accepted for processing, and then you'll get an observatory code request. So these are what we've done as far as what we've put out. So this was a submission we did the other day, and you're going to get an actual observatory code request form that you would fill out for that. So that's what that is. So that's how you would upload that file to the Minor Planet Center. And they also have other formats as well. You can go to the Minor Planet Center and look at all that stuff. There's a lot of information out there to look at and check out. But basically, that's how you do it. And yeah, that's how you measure these asteroids, and that's 1998 that we just took some measurements on the other night. We submitted to the Minor Planet Center. They really want you to get a couple nights observation in a 2-week period, like a 14 or 15 day period is when they want you to do it. So if you're going to observe, you want to do it and then try to reobserve quickly within a few days. We try to do it within a few days, couple days. If I'm going to observe like tonight, I will make sure I would observe tomorrow night or Monday night, the latest. Or or sometime during the week, just so I have. So basically the same as using Raza. Yeah, exactly. So yeah, both Christophers. That's right. So we basically have a Hyperstar system that we're using. Let me see here. I've got we got pictures of it all over the place on our website and all kinds of stuff like that. So this is our 8-inch. And there's a Hyperstar system. So we're replacing the secondary with a Hyperstar camera. And that's basically how we shoot right there. Just like a Raza. Raza is the same unit. The nice part about our scope that I really like, Razas are totally awesome, amazing scope, but they're only for imaging. You cannot observe with them. With our telescope, we can observe if we wanted to, so that's the nice part. But you do have to remove that mirror. So you're actually pulling that mirror out of the unit and replacing it with the camera. So that's how that system works, Chris. So Hyperstar is really nice. Really nice system. We're shooting with ZWO 1600 camera. I'm just shooting monochrome. I don't need color because of what we're shooting with, what we're shooting after, going after asteroids. So, but yeah, it's the images of the Raza is unbelievably nice. There's a lot of guys. I know Dylan O'Donnell shoots with that as well. We're trying to get him on the channel. He follows us. We love Dylan, and we're trying to get him on as a special guest. Shout out to you, Dylan, if you're watching. We're trying to get him on here because he loves to collect. He loves asteroid stuff too. So we want to talk to him about this stuff. He's doing a lot of stuff down there in Australia, and I know he's into it as well. So it's totally awesome. I'm just looking at the chat questions here. 8-inch ZWO. Yep. Hyperstar. Yes, that is true, Christopher. It does end up costing a little more to have that. So if you're just looking to image only, the Raza is absolutely the way to go. For sure, but a lot of people do have. Some guys have. If you have an 8-inch SCT right now, you don't need an edge. You can run with a standard as well. They work just as fine. And in fact, we had a standard 11 we used for a long time. Telescopes.net, Woodland Hills Cameron Telescope, gracious enough to let us use their Edge HD 11, which is just phenomenal. Love the telescope a lot. We just love it. It's just such a great unit. In fact, it's right here behind us. That's our 11 sitting right there. And I have a PhD. I have a guide scope on there that I use as well, mini guide scope. So, but we've also collected data with our 8 as well, our 8-inch over here. So that we have wrapped as well, and it works extremely well. But what's nice, you can do both. So if you have an Edge or if you have a standard SCT, you can get conversion kits and run them as well, and they work pretty well. So I'm just any other questions, you guys? So I just wanted to kind of go through with you guys. I know I get a lot of questions about people asking me about how do you do the asteroid thing, and so yeah, the wrap. We love the wrap, man. Wrap turned out pretty well. There's a little video on YouTube on it. The gentleman that did it for us did a little video and posted it for us. So we're going to get some more images of it soon. But it came out pretty well. So, and you guys can, man, if you guys have scopes, want to get wrapped, man, Michael D Inc., man, just shoot me a message, and I can definitely connect you with the guys that do the wraps, and they do a phenomenal job. So, pretty inexpensive too. It's really great great guys down there at Michael D Inc. doing that for us. So, all right, well, I'm if no other questions, I'm going to wrap this thing up, and let me go here. So I appreciate you guys coming by, and we're gonna wrap it up right now. Yes, I know, Christopher. We've been with my son. My son had finishing up school and summer break, and we've had some vacation stuff and work stuff, a lot of stuff going on, and it's been really difficult to get streams going. So I actually have an LX85 I need to do an open box on, and I need to do that. So I'm going to try to do that hopefully this week, and get that going. And we're going to image some asteroids with an LX85 with our 8-inch, because I have Hyperstar with that, and we'll show you guys how to do that with like $600-700 mount. Looking forward to that. I want to show some Mead products as well. Love Mead stuff. It's really great stuff. But I know we've got to get some more videos out there. So. All right, appreciate you guys coming by, and feel free to join the Discord, subscribe to the channel, follow us on YouTube, follow us on Twitter. We're Asteroid_Hunters, I believe, is our Twitter, or not Twitter. I mean, I'm sorry, Instagram. Apologize, Instagram, not Twitter. Follow us on Instagram, and then we'll leave a link to the Discord. You can ask questions in our Discord channel that we have going on. We've got pictures and news, and you guys can post pictures of your setups and ask questions, and feel free. I get questions from guys all over the country. I'm even getting questions from guys in India now, people all over the world. So keep them coming, man. And again, check out telescopes.net, telescopes.net, man, and use that promo code Asteroid Hunter when checkout. When you guys are purchasing stuff from telescopes.net, you're going to get a discount on your order, man. Even if you call them and say, hey, man, I watch the Asteroid Hunter channel. Can I get the Asteroid Hunter promo? They will give you a discount over the phone as well. But that's the promo code for the website, telescopes.net, man, for all your stuff you guys need. So, all right, guys, you guys take care. Thanks for coming by, and we will catch up with you again.